We continue with elasticity. Hooke's law. So we found that by producing strain on a body, you can see that a stress is developed. So the stress is found to be directly proportional to the strain. That means the straining increases, the stress is also increasing. But remember, if you go on strain a body, for example, you stretch an elastic body, you are stretching it. Initially it is going back, but if you stretch it further and further and further, it comes to a limit beyond which if you stretch it, the body cannot regain its position. Either it stays there in the elongated position or it breaks. So just before that, the body can be elastic. That particular level up to which the body can behave as elastic, we call it as elastic limit of the body. So within the elastic limit, you can find that the stress is always directly proportional to strain. And Hooke's law states the very same thing, that within the elastic limit, the stress developed on a body is directly proportional to the strain produced or applied on it. That is, stress is directly proportional to strain, that stress divided by strain remain a constant. We represent it as mu, called modulus of elasticity. Modulus of elasticity of the body. Modulus means the measure of the elasticity of the body. Because by finding this value of modulus of elasticity, you can see how much elastic the object is. For example, if there is a question comes like, which is more elastic, rubber or steel? You will be answering that based on the modulus of elasticities. Which is having more modulus of elasticity, that is more elastic. Okay? Now, when you define this modulus of elasticity, you can find that it is stress by strain, and the unit of modulus of elasticity is nothing but Newton per meter square, because strain is dimensionless, unitless. So modulus of elasticity is same as, unit of modulus of elasticity is same as that of stress or that of pressure. Okay? Now, we studied three different types of strains. So depending upon that, we will be able to define three different moduli of elasticity. Now let us see what they are. First one, Young's modulus. Young's modulus. Young's modulus denoted by Y. It is the ratio of linear stress to the longitudinal strain. Linear stress to the longitudinal strain. F by A divided by delta F by N. This can be rewritten as F by A into L by delta L. If you want to rewrite, it's like this. But remember this one is denoted by Y. This is named after a scientist called Young. Now the second one is based on volumetric strain called bulk modulus. denoted by K. Bulk modulus is defined as the ratio of normal stress to the volumetric strain. Normal stress to the volumetric strain. But this normal stress is taken as pressure P divided by delta V by V. Now relating to this bulk modulus, we can remember another equation that is very important. Reciprocal of bulk modulus. Reciprocal of bulk modulus is representing compressibility of the body. How far the body can be compressed. If the bulk modulus is large, then compressibility will be very, very small. It's very difficult to compress that object. Okay, that equation is very important. Now the third one is rigidity modulus. Third one, rigidity modulus. Let us see what it is. Third one, rigidity modulus denoted by N. Actually, this is defined as the ratio of tangential stress to the shearing strain. Tangential stress to the shearing strain. That means F by A theta. These are the three moduli of elasticities you are supposed to remember. Young's modulus relating to linear stress, then bulk modulus relating to bulkiness, bulky relating to volume, then rigidity modulus, how rigid the object is. When you twist an object, how rigid it can be to be understood. So that's relating with the rigidity modulus denoted by what we call it, just depending on what you call the tangential stress to the shearing strain. Now depending upon the states of this matter, solid will be having all these three types of moduli, but liquid you cannot stretch it. There comes only volumetric strain. In the case of gas, there also the volumetric modulus is possible, that is bulk modulus is possible. So depending upon the nature of the material, state of the material, you can have this elasticities assigned to them, depending upon the. Okay, so these are the three equations to be removed.